Hello, and welcome to another video of Cornerstones of Math. With this video, I am going to start another video series, this time about probability distribution and some basic statistics. Now, some of you might want to say, what do you mean probability distribution? I hate probability and statistics. Well, this video isn't just about probability and statistics. Here, we are also going to take a look at some interesting power series, like these. And while doing so, we are also going to do a little bit of calculus as well. That sounds pretty exciting, so let's get right on to the problem. Suppose rolling a regular die until a 6 comes up. Let x be the total number of rolls. A. Find the probability mass function of x. B. Find the expected value and the variance of x. Alright, so first, the probability mass function. This simply means the expression for the probability of our random variable x having specific value, say some natural number k. We will denote such probability as px equals k. Now, the total number of rows being k means we get 1, 2, 3, 4, or 5 for first k minus 1 rows, and finally get 6 at the kth row. So we have probability of x being k equals probability 5 over 6, k minus 1 times 1 over 6. And this is our probability mass function. Yeah, this is it. If you write 1/6 first, then we have this times 5 over 6 to the power of k minus 1, where this k can be any natural number. So this is the answer for the problem A. And now the second part, the expected value and the variance. So the basic definition of the expected value and the variance is like this. Expected value is the sum of k times the probability of x being k for all possible values of k, and the variance is the summation of k minus expected value squared times probability for all possible values of k. However, for the variance, using the relation, variance is mean of squares minus square of mean is simpler than using the former definition of variance. So we are going to use this formula instead. Now, using our previously obtained probability mass function, we have expected value as 1/6 sigma k times 5 over 6 to the power of k minus 1 from k equals 1 to infinity. You know, because this k can have the value of every natural number. So this is expected value. And the variance is 1/6 sigma k squared 5 over 6 to the power of k minus 1 from k equals 1 to infinity minus expected value squared. Note that the expected value and the variance are expressed as power series or just simply called series. Being able to calculate these types of series are very important since they appear quite often, and there are actually two ways to calculate the sum of these series. One is without calculus, and the other is with calculus, and I will show you both methods. So the first method, without calculus. Here, in order to calculate the expected value, we need to calculate this sum, and let's just call it S. So in an expanded form, we first have 1, then 2 times 5 over 6 to the power of 1, then 3 times 5 over 6 to the power of 2, then 4 times 5 over 6 to the power of 3, and so on. And let's just call this 1. Here, the individual term consists of the product of arithmetic progression and geometric progression. And the geometric part has a common ratio of 5 over 6. The trick here is we multiply this 5 over 6 to s. Then, this part now becomes k times 5 over 6 to the power of k. So the first term is 1 times 5 over 6 to the power of 1, and the second term is 2 times 5 over 6 to the power of 2. Then we have 3 times 5 over 6 to the power of 3, and so on. And let's call this 2. Then, 1 minus 2 gives 1 over 6s equals, so we have 1. Then, if we do this term minus this term, we simply have 5 over 6 to the power of 1. Then, this minus this gives 5 over 6 to the power of 2. Then, we have 5 over 6 to the power of 3, and so on. So now we have purely geometric series, and using the formula for the sum of geometric series, we have 1/6 of s equals first term 1 over 1 minus common ratio 5 over 6, which is 6. So we have s equals 36. And since the expected value is simply 1/6 of s, it is just 6. So this is the expected value. Next, the variance. Recall that our variance was given like this. So now we need to calculate this series, and let's call it t. Here, the previously arithmetic progression part is no longer an arithmetic progression, since now we have k squared here. So here, we use the famous yet very clever trick of splitting k squared into k minus 1 plus k. Then, t can be written as now k minus 1 times this plus k times this. And this second part is just s, so we can just write plus s here. We want only the series on the right hand side, so let's move this s to the left hand side. Then we have t minus s equals this series. And the term becomes 0 when k equals 1, so we start from k equals 2. Then we have 2 times 1 times 5 over 6 to the power of 1. Then the next term is 3 times 2 times 5 over 6 to the power of 2. Then 4 times 3 times 5 over 6 to the power of 3, and so on. And now you know the drill. If you multiply 5 over 6, then we have... So this part becomes k, so now we have 2 times 1 times 5 over 6 to the power of 2 plus 3 times 2 times 5 over 6 to the power of 3, and so on. Similarly, we subtract the bottom one from the top, so we have 1/6 t minus s equals, first we have this term, then for the next term we have 2 times 3 minus 1, so we have 2 times 2 times 5 over 6 squared plus 3 times 4 minus 2, so we have 3 times 2 times 5 over 6 cubed, and so on. And we can write the right hand side as 2 times first 5 over 6, then 2 times 5 over 6 squared, then plus 3 times 5 over 6 cubed. So if we take out 5 over 6 to the outside, we have 1 plus 2 times 5 over 6 plus 3 times 5 over 6 squared, which was our definition of s. So we have 1/6 t minus s equals 5 over 3 s. And if we solve for t, we have t minus s equals 10s. Therefore, t equals 11s. And since s is 36, we have 11 times 36, which is 396. Therefore, our variance is 1/6 of t. And here, let's actually use 11 times 36 and minus expected value squared, so 6 squared. So we have 66 minus 36, which is 30. And this is our variance. Alright, so that was the method without calculus. And now, the second method with calculus. So the process is basically the same. We have to calculate the sum of these series. And for that, consider a geometric power series, the summation of x to the power of k minus 1 from k equals 1 to infinity. And let's call this fx. This series converges for x whose absolute values are smaller than 1, and the sum is simply 1 over 1 minus x. In this converging range, if we differentiate the series, we have k minus 1 times x to the power of k minus 2, and since this term gives 0 when k equals 1, we can write k is from 2 to infinity. And if we differentiate this function, we simply obtain 1 over 1 minus x squared. Now if we change the summation so that it starts from k equals 1, then we have k times x to the power of k minus 1 here, and this equals 1 over 1 minus x squared. And from here, Note that our expected value is simply 1/6 times f prime 5 over 6. So using this expression on the right hand side, we have 1/6 times 1 over 1 minus 5 over 6 squared, which gives 6. So that was the expected value. And now for the variance. Note that in order to calculate variance, we need the sum of this series. So here, let this sum of k squared times x to the power of k minus 1 as gx. And we will also use this k squared equals k minus 1 plus k here. So gx can be written as sigma k minus 1 x to the power of k minus 1 plus sigma k times x to the power of k minus 1, which is our derivative f prime x. Right, so now we have to find out this part. Here, recall that our derivative f prime x was given like this. If we differentiate our given derivative again, we have f double prime x equals sigma. We now have k times k minus 1 times x to the power of k minus 2. And we can start the summation from k equals 2 because k equals 1 just gives 0. And if we differentiate the right hand side, we have 2 over 1 minus x cubed. So we have k minus 1 x to the power of k minus 2 here. But here we have k times k minus 1 times x to the power of k minus 1. It has additional x. Therefore, we multiply x here. Then this becomes x to the power of k minus 1. And we have 2x over 1 minus x cubed. And the summation can start from 1 or 2, it doesn't matter. But let's write 1 because we have k equals 1 here. So notice that this part equals x times f double prime x. So our gx, which is the sum of k squared x to the power of k minus 1, can be expressed as x f double prime x plus f prime x. And using this and this, we have 2x over 1 minus x cubed plus 1 over 1 minus x squared, which gives 1 plus x over 1 minus x cubed. And from our expression for variance, this part is g 5 over 6. Therefore, variance of x is given as 1/6 g 5 over 6 minus expected value squared, so 6 squared. So we have 1/6 times, using this expression, 1 plus 5 over 6 over 1 minus 5 over 6 cubed minus 6 squared. So the first term will give 66, and the second term is simply 36, so we have 30. And that was the calculus method to calculate one of the most famous power series. Thank you all for watching, and I will see you in another video.